This lecture is going to go over how we measure a construct, and more specifically, how we decide what measure is going to be appropriate for us to use in a study. So just a refresher before we get going, what is a construct? So constructs are abstract phenomena. It means we can't measure them directly. So this can be a lot of different things, including thinking about thinking, uh, people's beliefs, their values, their emotions. Like they're real things, but I can't, stick a ruler up to your head and measure how you are thinking. I can't physically measure it. So in psychology, this is where this comes from. Psychology uses constructs as ways to think about a particular phenomenon that we can't directly measure, but we can try to get close in measuring this abstract thing by using different kinds of measures. So one way we can exemplify this is with circles. So say I have my construct, I have math anxiety. I can't necessarily directly measure math anxiety in the sense that I can't stick a ruler up to you and figure out how much math anxiety you have. But we have a lot of different ways that researchers have across, looking at this subject, made ways to measure math anxiety. So I could have a student survey where I'm asking you particular questions. Maybe it's a Likert scale. How much do you agree or disagree with these statements about uh, does math make you feel like jittery or things like that, where I can use those statements and how a person agrees or disagrees with them to get an approximation of how much they're experiencing math anxiety. Another way we could look at this, we could potentially do a clinical interview where we have a series of questions we are asking the person and we're trying to get at how they, experience math. What is going on when they're taking a test? Can you tell me, when you hear your teacher announce a test in math, what feelings come up in your body or something like that? Like, we can ask questions like that. We can also look at behavior too. So it isn't necessarily just me talking or getting data directly from the student. I can also see what the student is doing in the classroom. So maybe when a math test happens, I sit in the classroom and I watch the students. Which ones are fidgeting more? Which ones do I see them put their head down on their desk while they're working, or something like that? Behavior indicators that could potentially indicate the student is struggling potentially with anxiety or stress. A stress response may or may not be anxiety. We could also take this from the teacher perspective too. So the first three circles have all really focused on the student's perspective. We can look at the teacher as well. How do they think about math anxiety in their classroom? What do they do to address it? Do they do anything to address it? That could also be something I'm interested in. So looking at this, you might see that these circles all kind of overlap on my blue construct of math anxiety. None of them cover it completely because there are things that some get that the others don't get. So I might not get the same information I can get by watching them take a test from the survey. And that could be for a myriad of reasons. Maybe the student doesn't know how physically anxious they're behaving in the test, so they don't rate themselves very high on the survey, but I see them taking the test and they're actually physically uh, having quite a lot more anxious behaviors than I would have guessed based on their self-report. So partly this is an illustration to show why we often don't want to rely on just one measure, but also different measures are doing different things, and not all of them are perfect. Uh, so we can't necessarily rely on one to try to get a full picture of what's going on. And you could potentially expand that circle even bigger because right now we've really focused on the core setting of, being in a math class, being a student in a math class, being a teacher of a math class. But we could expand that out even bigger. We could think about how do the students' parents think about math? Did they have math anxiety? Uh, how does the community around the student uh, talk about math? Is it favorable? Is it a scary entity? You can kind of expand all the way to the country, more or less, behavior and beliefs on the construct of math anxiety. Like you can kind of go really big with it. So how we think about a construct also depends on what level, I guess, you are thinking about it as well. So for the sake of this one, though, we're thinking about the student and the teacher level. So I mentioned 4 different ways I could potentially measure math anxiety on that previous slide, but what makes a good measure? Well, starting off, it's got to be valid and reliable. At minimum, that's what we're looking for when we're looking at the quality of research. Did you use valid and reliable measures? And ideally, it's been validated and it's been tested for reliability with your specific population and for your specific research focus. We can't always get there, but those two things are really important because validity and reliability often depend on where and how that measure has been designed. So let's think about this for population first. So say I've developed a measure, I've written it in English, and I developed it thinking about undergrad college students as the people I want to use this measure with. That's fine. I can use, particular language, being a native English speaker, knowing kind of the general culture, that I can make particular kinds of questions and use specific kinds of wordings to get the data that I need from that particular population. But if I took that same measure and say I gave it to elementary students in Japan, they may not actually be able to not necessarily take that measure. Well, if they don't speak English, they couldn't take that measure. So there's, a big limit barrier of you didn't translate it into their language. But also, I might use particular cultural things that make sense to 2024, United States that wouldn't make sense to somebody who isn't in that culture at all. So by giving it to these elementary students in Japan, they may not have any idea, even if they can read it, they may not have any idea what I'm talking about because I've designed this measure for my specific population, which is not this other population. So that would put me in danger to be a not valid or very low validity on this measure. The other way this can be impacted is if we think about our research focus. So we can think back to our math anxiety example. So I can use, potentially, I might try to use a standard anxiety measure that they would give you if you went to the counseling center and they're just doing their battery of tests for kind of diagnostics. That would be a general anxiety measure. It's going to ask you very somewhat generic questions like how often in the past week have you felt on edge, or have you been how often have you felt, or have you felt very fidgety, or things like that, where like it's not specific to anything, it's just in general because they're looking for generalized anxiety measure. That's fine. But if I tried to take that and put it into this math anxiety study, I might not actually be capturing math anxiety. I'd be capturing anxiety, generally speaking, but just because somebody scores high on an anxiety measure doesn't mean they have math anxiety specifically. They could just have normal anxiety and they're anxious about everything. Math anxiety is fairly specific in that it's that particular subject that you have anxiety about and not other subjects. So by using a general anxiety measure, I'm not actually getting the data that I want because it's not specific to my research focus. So you want both to be specific to your population and specific to your research focus. The other thing you want to consider in terms of a good measure is that it doesn't cause test fatigue. And we don't usually have this problem nowadays because often we're trying to make as efficient measures as we can. But depending on what you're trying to measure, the longer a test or assessment takes, the more whoever your participants are going to get tired of it. And that can be not great, for the first time they take that measure, but especially if you're going to be measuring at multiple points in time, like maybe I want to use this math anxiety measure 6 times throughout a semester. If that measure is like 60 questions long, eventually students are just not going to answer it. They're going to be done. So I want to make sure I'm not using a measure that is super difficult or super long, like taking long to complete, because I'm going to lose data by test fatigue, and I don't want that to happen. And the other thing you really want And assuming you're using a valid and reliable measure, you're probably going to have some amount of your construct explained by your measure, but you really want to get as much amount of your construct as you can with your measure. So a measure that might be valid and reliable, but maybe it gives me, I don't know, like a 10% sliver into my construct. It gives me some data, but it may not be worth it to add it on if I've already got another measure that gives me 25 or 30%. Especially if we're thinking about test fatigue, that can also be in the case of giving like a battery of tests. So I want to use as minimal amount of measures that help me get the data I need without fatiguing my participants. So if my additional measure doesn't give me much in the way of data that explains, more in addition to what I'm already collecting, I don't just want to tack it on because it's going to make more work for my participants and it's going to make more work for me as the researcher too. So speaking of the number of measures you might be considering, how many should you actually use? In my opinion, I would say ideally more than one. Because if you think back to that circle example on that first slide, depending on what you're measuring, you may not have measures that can really capture most of it in one go. So you do want to get, as much of that circle as you can, but there is balance to how much you can actually do that. So some constraints that we can see when it comes to measure selection can be constraints of time. So some measures take more time to collect data with. If you're doing observations, you need to be there for that whole class section. That's potentially an hour or maybe 2 hours, depending on the class. Whereas a survey, it's done at the pace of the participant. You don't have to sit there and like proctor it or collect the data actively. Depending on your measure, this could also be considering how long the measure itself is. So thinking back to that test fatigue, picking a measure that is 20 items versus 80 items, you might want to opt with the 20 items if it's valid and reliable, because it's going to take way less time for your participants to fill out compared to that 80 item measure. And related to that, the more data that you collect, the more that you have to analyze. So often we also have constraints on resources, and this is both, it could be actual physical resources of getting the measure to the people, but also resources in terms of personnel. Do you have enough people to do the data collection, to do the analysis? Because if you just collect a bunch of data but you can't analyze it, you're going to get bogged down in your data, and that's not very good. And then there's also a concern or a constraint of availability. And this I kind of hinted at when I was talking about validity and reliability, but sometimes there's not a measure that is directly made perfectly for your research situation. So when it comes to that kind of scenario, I often see two things happening. One, I see some people modify related measures. So maybe I take that general anxiety measure, but I modify the questions to specifically address the math anxiety context. So how many times this week in your math class did you feel fidgety or restless? So rather than it just being how many times this week did you feel fidgety, I've made it specific to my context. I would want to validate this and test reliability after I've done these modifications, which researchers are supposed to do. Doesn't always happen, but you can take this approach, especially if there are already really well-established measures out there that all you need to do potentially is maybe tweak some words to change the context to be your specific context. I see this often in the science education literature when a measure has been developed in a particular science domain. So say a measure got developed in, physics education, but then a biology education researcher wants to use it, they probably don't want the physics terminology that's in the measure, but they can swap it out with the biology terminology and still be able to use the measure. And it's usually fairly reliable if the context is similar. So you can modify a measure potentially, and that would save you time because the other option really is make your own measure from scratch. And some people do that. I mean, that's how we get measures, is somebody decided I need to measure this thing, I'm going to make a measure to do this thing. So people definitely do that. However, that takes a lot longer time to do especially if you're doing that and then you're doing a research on top of it. Often that's like a person's career path is I made this measure, now I can do the research that I wanted to do, even though it's, 5 years later. So if you've got the time and resources yourself, you can make your own measure. But often people are modifying measures to suit their needs because there isn't one out there for their specific purpose. And again, when we see those things, we want to check if they've modified it. Did they do more validity and reliability to tell us that their modifications didn't alter the quality of data that this measure is going to generate? So how do you unite data from multiple measures? If we've decided that we should use at least 2 measures, so more than one, how do we unite them in thinking about a construct? This is really where the theoretical framework matters. And not only so that you can understand why they picked the measures that they picked, but also how they are interpreting the data that comes from those measures. And this can happen in multiple ways. So you may actually, and we've often seen, more than one theory to address different components. And this often in what I see is we see a uniting of a cognitive theory with a social cultural one to kind of provide a bigger perspective, but maybe you might have multiple cognitive ones or maybe multiple social cultural ones. It all depends on what you're trying to research. So when it comes to theoretical framework, it doesn't mean there is one theory that we have to use. It's just kind of a bucket that we have for the theories we're using to try to understand the relationships of what's going on in our research. So we might have one, we might have 3. It really depends on what you need to do your research. And when you're using multiple measures, especially if they're getting multiple perspectives, it helps to have multiple theories that are designed for each perspective. And depending on how your little subtopic looks in literature, your theory might actually already include multiple aspects. So it really depends on what you're looking at, whether you have to kind of stitch together multiple theories or somebody has already done that and you can use their compiled theory for yourself. So talking about that in abstract can sometimes be a little bit hard to understand what that actually looks like intellectually. So let's go through an example. So let's stick with that example of math anxiety. So let's say I've picked some measures. I wanted to do a survey, specifically a math anxiety measure. Maybe I also wanted to observe their test behavior like I was talking about before, and let's say I did some interviews with students as well. So what theoretical frameworks could I use for each of those different data sources? So I could potentially use a cognitive theory, information processing, to potentially look at students' test behavior. Maybe I'm looking at it to specifically see, is the test designed in a way that is overloading to read? We're getting kind of like, we're hitting the student's threshold and for how much information they can actually take in at once. So it's kind of like looking at the test itself, what is actually happening there in terms of the cognition the student has to do to understand the test. So that's one perspective. I could also use modeling. If you've heard of Albert Bandura, he's the big social learning person. Modeling is essentially how children see adults or other children doing things in their environment, and they learn that that is the way to do things based on watching. So I could potentially use that as a theory to look at how students refer to adults around math anxiety. So maybe I have some questions in the survey, like how do your parents feel about math? Or maybe I'm asking them in an interview where I can get that in-depth information from them. I can see how students are talking about their teachers, their parents, other adults in their life, what behaviors those adult figures are modeling to this student that maybe give me some insight into why the student does or doesn't have much math anxiety. And then I could also take a cultural approach. So, and I kind of hinted at this on the very first slide, but I could look at what cultural values the student might have around math and its importance. And if I'm doing that, I'm not probably staying at the student level. I need to expand to the community level, region, culture, national culture, depends on what level I need to go to. But what are they talking about in terms of potentially how important math is? Is math something like you have to do well in to succeed in life? And if you aren't good at math, you're not a good person. That's usually a cultural belief and not just a family belief. It can, obviously, there is interplay in that because family is influenced by the culture around it. But often we can look at large cultural beliefs in terms of uh, ideas like math anxiety, because not everywhere has problems with math anxiety. So we can look at why some countries do or don't have math anxiety, and I can look at this, take that information, and use that approach to look at the context of where my students in this study are. So all of that was looking at math anxiety, and I used different measures to help me get different perspectives into this phenomenon of math anxiety. So when it comes to looking at how researchers design their own studies, we want to see when, especially when they're using multiple measures, how well were they able to kind of interweave the different data sources that they're giving? Or are they just collecting a bunch of different data to collect data, but it's all kind of separate? A well-designed research study is going to feel very knitted together, both in all of the data either talks to each other or provides multiple facets of perspective, or the theoretical framework that they use to interpret all that data helps mesh all of that information into a holistic perspective. So when we're reading research, we do want to look at how they use their theoretical framework to understand the measures, because that helps us interpret their data, but also it helps us understand how the researchers themselves are approaching this construct. And that might be important because you might be looking for a particular approach. Um, so when we think about theoretical framework, it isn't necessarily just figure out what it is, especially when you're getting into research, not doing it necessarily, but just using it. Knowing the theoretical frameworks that work well for your context, your thing you're wanting to research, it helps to know how the researchers are using it, because sometimes people will say they're using a framework and it doesn't make sense. So we want to see not just are they using a theoretical framework, but how are they using that theoretical framework, particularly in this case, to unite different data sources.